2.6, it gave us this equation which I graphed. It's an upside down parabola at it's upside down parabola up 16. So I moved up to 16. When x is 0, it's there. When x is 1, either way, it takes it down 1. When I go over 2, it takes it down 4. When I go over 3, it's down 9. 4 down 16. So it crosses at 4, 0. It says be in the first quadrant, make a rectangle in here that could be at any point on this curve. So it can be moving, the point can be moving anywhere, so the width is going to be wherever is underneath it. So I'm just going to draw one here, and it could be any place here, so I'm going to say it's over someplace x. And to get the height, I would plug whatever x was into this equation, and so the height will be 16 minus x squared. And the area of the rectangle would be width times height. And so the domain, since I got to be in the first quadrant, x has got to be somewhere between 0 and 4. Really doesn't make a rectangle at 4 or at 0, so they in the book said go from 0 to 4, not including those. I could say, well, it goes clear to 4, but it would have no dimension, it would be 0 height in it, but so it's not really a rectangle, but so that's why they didn't put the 4 in. And it says find the max. And so I'm going to type in my area formula into my calculator. Oh, and look at it, I have the x on the other side there, but that's it. And see, the area is going to be, my domain is from 0 to 4. And the area is going to be somewhere between 0 and, let's see, 16 by 4 would be 64, so it's probably never going to be up to there. Probably never more than 40, let's say. And so now I'll graph it. Yep, didn't get over 40. Looks like it got over 20 though. And there's a maximum, and it says find the maximum area. And what x makes it, so second, calculate the maximum. And it's somewhere between 0 and 4. So I'm just going to say that, between 0 and 4. And it's probably around 2. And it says it's going to happen at x equal 2.3. And the maximum area, so I probably should, since it's asking for the maximum, that the maximum is 24.6 square units at x equal 2.3. Now I don't know whether they just asked for the x coordinate where it's max or the maximum value. So you'll have to decide which one of those you have to give. 10 says we have this circle inside a square, and it says write a function of the area of the square, a function of r. Well, the square is length times width. This is r plus r, so this way is 2r. And of course this is 2r, so the area is going to be 2r times 2r, which I could either write as 2r quantity squared, or 2 times 2, 4, r times r, r squared. You can write it either way. Perimeter, well, that's simply add them up. 2r plus 2r plus 2r plus 2r. That's 8r. Now it says do a similar thing for this one. Now we're talking about the rectangle and only half of it, so the area of the rectangle is going to be 2r, because it's r plus r, and then the height is just r, so it's 2r times r, which is 2r squared. Perimeter of the rectangle is pretty simple. 2r plus r plus 2r plus r. 2r times 2, or 4r plus r plus r is 2r, is 6r. And then finally, the volume of the cylinder as a function of h. How do I find the volume of the cylinder? Let's see, that's area of the base since the radius of the base is little r, times how tall it is, h. Is that a function of h? Well, there it is, but not there, and r does change. So I got to figure out how to replace little r with something that has the big R, a constant. It's not changing. We got one size sphere. And the can is h tall. And if you look here, we see a triangle where if this is h, from the center of the circle to here is h cut in half, half of h. I could write 1/2 h or 0.5 h or h divided by 2. And Pythagoras says there's something true about this. It said leg squared plus leg squared is hypotenuse squared. And I can use big R because it's constant. It doesn't change. But little r and little h change as you change the width of the r. The cylinder gets smaller. If you move it shorter r, the cylinder gets taller. So we got to replace r squared. Well, if I just subtract this from both sides, I know what to put in place of r squared. So I get pi r squared, which is capital R squared, minus h over 2 quantity squared, all of that times h. And there's the function of the area of the volume of the cylinder as a function of h's only. 21. We're supposed to find the volume of the cylinder again. Okay, so that means it must be pi r squared h, and we're supposed to have it in function of r, and we're pretty good except for that, h. We've got to get the little h out of there. And what you have to be good at is seeing triangles on this one. The really big triangle, the little triangle at the top, and let's see, different color here. How about this one? And the little triangle over here, the purple one. There are 3 triangles there that all have the same angles in them. They're different sizes, so they're proportional, and we have nothing on the hypotenuses of either the purple one or the green one or the red one, but we could do the ratio of the legs. So I'm trying to replace h. H is from here to here, the height of the cylinder, which is this one. So I'm probably going to use this one, which has h2. I don't want to do hypotenuse because I have nothing on it, but I can get the denominator, the base of this. Not so easy. This is little r. This is big R. So this purple base out here is big R minus little r. Now I want to do it for a different triangle, either the green one or the red one. Well, the red one is fixed. The whole big one is fixed. It has a height that's always h, and the base here of always big R. So this is a constant. So if I want to place h with something, I got to move this to the other side somehow. H divided by that, to get rid of it, I multiply by it on both sides. Cancels. And I get h is equal to this, and so that's what I'm going to put in place of the r. So this becomes pi r squared capital H times r, capital R minus little r, divided by capital R. That's the function of the volume of the cylinder as a function of r, because there's only little r's in here that vary. The capitals are constants. So there's my answer. Okay, and finally the last one, 25. It says we got a square piece of cardboard. We're going to cut the corners out and fold it on the dotted lines here and make a box that looks something like that. And it says write the volume of the box as a function of x. Well, volume of box is length times width times height. Let's see. The length. That would be from, not from here to here, but from there to there. Well, that's almost 24. It's 24 minus x on this side and minus x on that side. So it's 24 minus x. So the length is 24 minus 2 x's, one on each side. The width, well, that's this one, which is kind of the same thing, 24 minus 2x. So I could have just said squared on this one, because two of them multiply by themselves is squared. And now the height. Well, it's not either of those. It's, let's see, when I fold this up, this becomes how high it is. So the height is just x. And that's going to be the formula for the volume of the box. And then it says figure out the volume when you've got 3. 3 times 2 is 6. 24 minus 6 is 18. Yes, 18 times 3 is 18 squared times 3. 972 cubic units. Actually inches, because they said inches. Now when it's 10 and 10 is 20, so there'd only be a 4-inch bottom. 4 by 4 by 10. That's 160, but we can work it out here. We put in 10 times 2 is 20. From there, that's going to be 4 times 10. 16 times 10 is 160. Now we could actually find out what makes the maximum. What's the side square to take out to make the maximum? I can go to y equals and go 24 minus 2x, close parentheses, squared, that thing twice, times x. Let's see, x can be something between 0 and 12. So I'll set the window from 0 to 12. And y is going to be somewhere around, somewhere between 0 and, if it was 10 by 10 by 10, it'd be 1,000. So I'll put 1,000. And I better, 1,000 there. And mark it every 100 on the graph. And now let's see what we get for a graph. Oh, it even goes over 1,000. So if I wanted the maximum, I would go second, calculate the maximum, and it looks like it happens somewhere somewhere between 0 and 12, probably around 4. So second, calculate the maximum between 0 and 12, and somewhere around 4. And it says 4 gets me 1024, and that's it. 4 is where it's at. At x equal 4, we get a maximum is 1024 cubic inches. Okay? That is the last section.